We'll do your first pre-calc video. We're going to talk about functions. Functions is a pretty broad category, but it is something you've been dealing with since probably middle school. So I just put a really basic function up there, f of x equals 3x minus 4. And first up, I'm just going to look at how to find f of 5. So just should be a pretty easy kind of warm-up thing to look at. You plug in 5 for x, and no matter how complicated functions get throughout the year, when you've got an x here, and you've got a number you're trying to plug in, anywhere you have an x, no matter how many x's there are, you put this number in its place in all those spots. So we'll put a 5 right here. 3 times 5 minus 4. So that's going to be 15 minus 4, which is 11. Okay. Hopefully that wasn't too bad. Now, domain and range. We can't have functions without domain and range. And you've probably explored beyond just x and y values. But when I ask what domain is, the first response usually gets, oh, x values. And for range, y values. And that's sort of true, but what you really want to start thinking about is domain is an input and range is an output. So you can control the input. You can control what numbers go into the function. But if you want a certain output, really, again, all you can control is what goes in, and you have to let whatever comes out come out. So if you've got a certain thing you're going for as a range value, and that's a big exploration of our class in calculus, if you want a certain output, you got to know how functions work so you can put the right input into it to get the right outcome. That first example I gave you is pretty basic, probably like 7th grade level, so let's up our game a little bit here. What I've got is a piecewise function. So we're going to still find f of a certain value. That's our domain number right there. That's not our entire domain, that's just the number we're going to try to plug in. And we're going to see what we get at, which is our range. Now our function's a little bit different this time. We got f of x, but we got this big curly bracket, we got a couple different parts. We're going to graph these things in the next section. I'm not worried about graphing quite yet. Let's just make sure we understand how the function works mathematically or algebraically, plugging things in. And then we'll figure out how to plug in lots of values and get a graph out of it. But you've got two different it's almost like two different functions, but you've got these domains over here. All right? Now the domains are kind of already given to us. So when we look at a value we're trying to plug in, like 3, we got to see which domain it fits into. So just test it out. If you put, and again, I said anywhere you have an x, you put that number in. So if you put a 3 in all these spots, including these, well, these are the ones we need to check first. So is 3 less than 1? Well, in elementary school, you learn that's not a true statement, so we rule that out. So it's probably going to fit here. 3 is greater than or equal to 1. Yeah, that works. So if this is the domain that 3 falls into, this is the piece of the function we're going to use. So we'll plug in 3 right here, and that's how we'll get a value out. So again, domain is everything you could possibly plug in. This one's already given to you. We could basically plug in any number here, anything less than 1, and anything that's 1 or greater. That's every number that exists. So we can plug in anything. Now our range, that might get a little interesting, so we'll talk about how to play around with that in the next lesson. But that's the idea. Plug in anything that's possible to plug in and see what all the possibilities are for what can come out. All right, let's up our game a little bit more. We're going to find the domain for a function here. It's a little different. It's definitely a little more complicated than the first example. I put up here no calculator. If you're dependent on the calculator right now, that's something we're going to have to kind of wean ourselves off of. Throughout the year, we're going to be proving things, making sure you fully understand how the math works without a calculator. Don't let the calculator do the work for you. You've got to understand how it works, because to do calculus, you've really got to understand what's going on in the background. So we'll keep working on getting away from our calculator. It'll have its place, but a lot of times we're not going to be using that thing. So here's our function. We want to know what the domain is. In other words, what can be plugged into this? Before we take on that example, let's just go back over what makes a function. Vertical line test is still a great way to determine whether something is a function. So I just put a few examples up here. I gave some graphs, and we're just going to say whether it's a function or not. So a straightforward line. Well, if you run a vertical line across that, the test says, does the line touched more than one point at a time? So it's definitely only touching 1 point at a time. Now to put that into domain and range perspective, for any x value in the domain, it's only going to go or be matched up with, or I'll say mapped to a lot of times, like on a map. It's only going to be mapped to one y value. Each x gets mapped to one y value. So for every input, we have one output only. So that's a function. That's looking good. All right, this crazy thing below it here. Well, I didn't really mean for that to curve back. So it looks pretty wild, but as I'm going along, I'm only touching 1 point at a time. So that's the function. Now, this is a piecewise. That's an example of what, just in the last example, what it would look like. Now, I don't have to graph those yet, but we'll get to it in the next lesson. So this one's got a little jump in it. That's an open circle. We know open circles are not included in the graph, but closed circles are. So if I'm running my ruler along my vertical line, well, so far it's looking pretty good. All right, I get to here. Well, it's hitting a point down here, but not at the top, so that's okay. So that one is still a function. Now, some things that could be a little weird here. If that was filled in, so if we change it a little bit. Well, on that now, it's not a function because we're hitting 2 points at the same time. For one x value, it looks like it might be like -1. You're mapping to 2 separate y values, so that's not a function. So if it's an open circle, we're good. If it's a closed circle, we might have a problem. Now, as far as trying to figure out the domain, if these are kind of spread apart, it may be that our function works if we plug in x values that are from -1 and anything less than that. And maybe this is at like, I don't know, 0.5. So everything from 0.5 and up works. But there might be a little gap in some x values that just never get mapped to any points in the graph. So that's when you're trying to find a domain. You got to figure out which x values can be plugged into here and actually show up on a graph. And that's what we'll look at when we go back to this other example over here. All right, last one I put up. Hopefully that one's pretty straightforward too. It's pretty much failing all over the place. Anywhere we go, we're touching more than 1 point at a time. So that one is not going to be a function. So just to wrap it up one more time. Every x value in your domain should map to one y value in your output or your range. So if you get an x value, like say, I don't know, 3, that maps to 2 other y values, it's not a function. So my advice to you when you're trying to find a domain, assume it's all real numbers, unless you've got a pretty good reason to rule something out. So things that generally cause problems in graphs, like dividing by 0. Taking square roots, there's limits to that. We can't take square root of a negative and get a real number. So things like that, fractions and square roots, those are going to cause problems. We already, hopefully you've explored that a little bit. So we've got a square root going on here. We know that you can't take the square root of a negative and at least get a real number. It can be done, but let's just stick to real numbers for right now. So the first thing I need to look at, since I can't take the square root of a negative, whatever's inside of here, so x squared minus 9, it could be 0. That sometimes gets to be a sticking point. You can take the square root of 0. That works. You get 0. But we can't take the square root of negative. So whatever's there has to be at least 0. It could be bigger. It could be a positive number, but at least 0. Now, if you go through and just start trying to solve this, pretty soon you get to a weird solution. If we just flat out take a square root there, both sides. Now, when you take a square root, don't forget the plus and minus. That's vital in this class. It's going to come up all the time. But x is bigger than 3 and x is bigger than -3. Feels kind of weird. If we graph that on a number line, here's -3, here's +3. We are equal to, so closed in circles, shaded to the right. Just go by the x if you ever try to figure out the shading. X is bigger than 3, so bigger that way. X is bigger than -3, that's also that way. I mean, we've seen things like that, but that's usually they either go apart or come together. So I'm a little suspicious of this. So we need to do something called the interval test. So rather than just dive right in and say, all right, they're both this way, I'm going to make a number line, And I'm pretty confident 3 and negative 3 are important. We call them critical values from this point forward. So I think 3 and negative 3 are critical values. I think there's definitely something important happening right at those 2 points. I need to find out what for sure. So just test out something in these 3 different intervals and just see if it works. That's really all you got to do. So anytime 0 is a possible thing you can plug it in, it makes it really easy. So let's start there. If I were to plug in 0 for x as a domain value, well, let's see, that would be 0 squared minus 9. That would be negative 9. So just to be clear, f of 0 would come out to be the square root of negative 9. Not a real number. Let's just leave it there. It's not a real number. So things that are in that interval from negative 3 to 3, they're not going to work. They're never going to show up in the domain. Now, if I put in, like, say, 5, well, 5 is bigger than 3. That'd be over here somewhere. All right, that's 25 minus 9, so that would be 16. All right, that comes out to be 4, but the main thing is it actually works. It gives me a real number out. So the point is, I put in a real number 5, I got out a real number. So things that are bigger than 3, they work. You plug a number in, you get a range value out. And I'm pretty confident that a negative number is going to work. I'm going to try, or anything less than negative 3, that is, I'm going to plug in negative 5. All right. So if you put in negative 5, you square it, becomes 25. You get the exact same thing you got for positive 5 there. Point is, you plugged in a real number, you got a real number out, and that's the determining factor. Look for any word that may not work. Anywhere you might be divided by 0, if you're taking a square root. We know square roots have to be positive, so that's kind of the process you would